Alright, so Objective 6, we're going to focus on graphs and how to interpret them. We did a lot of motion labs with this, so now we're going to look at all of the situations that we'll encounter in this class. So the first one is going away at a constant speed. So looking at the position time graph, you have to think about, okay, it's going away. So do you start down here, close to 0, or do you start far away? Well, if it's going away, you're going to start close to the detector. So you're going to start down here at 0. And it's a constant speed, so that distance through time will be consistent. So it should be a straight line. That's about as straight as I can go on the computer. So picture that as a straight linear line. And then going away at a constant speed. Okay, you're going away. Now what you have to do when you think about it is think of the positive area. That means this is the 0 line. So anything in this positive area here is positive. And I try to tell people to think of at to remember it. A at the bottom, A at the top, T at the bottom. So the negative area is down here. So if you're going away, it's going to be in the positive area, and the T area is negative if it's going toward. So this is going away at a constant speed. That means what's true about my velocity? Is it changing or not changing? Well, if it's a constant speed, that means it's not changing. So you should picture a horizontal line, not changing, in the positive area. And if you're going faster, it'd just be a higher line. If you're going slower, it'd be a lower line. And then acceleration versus time, well, if you're at a constant speed and your velocity is not changing, your acceleration is 0. So it should be a line at the 0. And if you take a look at that, the slope of this line is positive. So your velocity is positive. The slope of this line right here is 0, so your acceleration versus time should be 0. Alright, taking a look at the next one, coming toward at a constant speed. Alright, so you're going toward. That means do you start close to the detector down here, or do you start far away? Well, if you're going toward, you gotta start far away. It's a constant speed, so that means your line would be a straight line, not curving. Well, think about that. You're going toward the detector at a constant speed, so you're going to have a negative direction because it's going toward. Remember I said think of at. So T toward is in the negative area. It's constant, so it's not changing. So it's a horizontal line in the negative area. And then looking at acceleration, well, it's not changing speed, so acceleration is 0. Plus if you look at the slope is 0. So your acceleration is 0 right on the 0 line there. So just to review, the slope of this line is negative, and we have a negative constant line for the velocity. The slope of this line is 0, so we have a 0 for the acceleration. Okay, so looking at going away and speeding up. So remember, this is position time. So it's going away, so you're going to start close towards the 0 down here. So we'll start down here, and it's going away, and it's speeding up. So we're going to go away, and it's going to speed up. Well, that means it's going faster and faster. So that means you're going to start off flat and get steeper. So you're going slow with a very gradual slope, and then after a while you're going faster and faster, so you should have a steeper slope. So it'd be a line curved upward. So looking at that, it's heading away. Remember to think of at. Away is positive, and it starts at a slower speed, so it should start closer to 0. And it gets faster, so it should go away from 0 if it's going faster. So that makes sense. Going away, it's always positive. You start off slow, closer to 0, and then you go faster and faster away from 0. So thinking of that, the slope of that line is positive. You have a positive acceleration somewhere above the 0 there. So coming toward, speeding up. So you got to start further away because you're coming towards. So remember, this is starting further away. So we're starting up here. And it's going slow at first. So we're going to have a flat, gradual line going toward the sensor. And then it's going to get faster and faster, so steeper and steeper. All right, it's going toward. So is that in the positive or the negative? Well, toward is in the negative. And it starts off slow. So it starts off at the 0 or toward the 0. And it goes faster and faster, so it should be heading away from the 0 line. Well, what is the slope on that? Well, it is negative, so you should have a negative line. You can also think if it's coming toward speeding up, there's something pushing it from behind, so that acceleration would be pointing towards the sensor, which is negative. So you can look at it two ways. You can think of the motion diagram or look at the velocity versus time graph and know that the acceleration is a slope. So this is a straight horizontal line in the negative area. Okay, next one here, going away, slowing down. So it's going away, you got to start close to the detector. So we're going to start down here, and it's going to be steep and then flatter because it's slowing down. It's going to be faster, so steeper, and then slowing down is flatter. Okay, so again, you're heading away. It's got to be in the positive section. And we're going to start up a little bit higher because at first we're going faster, and then we're slowing down. So I'm going towards the 0 line there because you're slowing down. So faster then slower, all heading away. Looking at the slope of that line, it is a negative slope. So your acceleration is negative. You can also think of the motion diagram going away and slowing down means something's pushing it back towards the sensor, and that push back towards the sensor would indicate a negative acceleration. So you can look at slope or motion diagram. The last situation then is coming toward and slowing down. So you're going towards, so you got to start far away, and it's slowing down. So that means it's going to be steeper in the beginning and go flatter. So in the beginning we want a steep slope, and then it's going to go flatter in time. So it would look like that, a curve going downward. So overall it's going toward, remember at, so it should be in the negative, and it's slowing down. So you want a line that's going toward the 0 because it's slowing down. Still all toward all in the negative section. Well, what's the slope of that line? Well, it's positive, so your acceleration is going to be a positive horizontal line in the positive area. And thinking of that, if you're going toward and slowing down, that means somebody has to be pushing you back away from the sensor. And away from the sensor, remember, is a positive direction. So you can think of it that way too. So that kind of wraps up all of our graphs that you'll see this chapter. One more thing I want to point out about graphs in Objective 7 is displacement can be determined by looking at the area underneath the curve of a velocity versus time graph. So looking at this graph, we have a velocity versus time graph, and I want to know the displacement at 5 seconds. All right, well right there's 5 seconds. And it says if I look at the area underneath this curve, I can get the displacement. I can figure out how far it traveled from the original position. All right, so I gotta get the area of this piece. Well, looking at that piece, what two shapes do you see? I don't know if you can see this or not, so I'll try to draw it. Right here you can see a triangle, and down here you can kind of see the rectangle, those two areas. So looking at the area of a rectangle, remember the area of a rectangle is 1/2 base times height. And if you look at this triangle up here, we have the height you have to figure out, which looking at that would be 30 meters per second because it goes from, 10 meters per second because it goes from 20 to 30. So that would be 10 meters per second. And then looking at that, it's 5 seconds. So it'd be 1/2 of 5, the base of the triangle, times the height of that triangle. And that triangle, like I said, goes from 20 to 30 right there. So 20 to 30 would be 10 meters per second. So that's a difference of 10. So 1/2 of 5 times 10 would give you 25. And if you take a look at the units, this is seconds. Remember, this is meters per second. So when you cross off the seconds, because that cancels, you're left with meters. So it makes sense as distance or displacement. Okay, the other piece that we have underneath the curve here is this rectangle piece. And we have to figure out the area of that, and that's just length times width. So we have the length, which is 5 seconds. And then the width, which goes from 0 to 20. So that would be 100. And again, meters. And so total that it would travel, the total distance or displacement, you'd have to add these up, add up those two pieces. So this is 125 meters. So you can actually get displacement or distance by looking at a velocity versus time graph by looking at the area underneath the curve. And sometimes if it goes down to 0, it's just a triangle. In this case, you have a rectangle because it doesn't go down to 0, and a triangle.